3.4 is about the derivative of trigonometric functions, and two of these derivatives you almost have to memorize. But after you remember the derivative for sine and the derivative for cosine, you can prove the rest of the derivatives using the product and quotient rule. And so we'll talk about these and we'll show some of them using the product and quotient rule. However, in general, you'll want to memorize these 6 derivatives, and there are 6 of them for the 6 most important trig functions, well, the 6 fundamental trig functions. So in the end, you want to just know these derivatives. It is possible on a test I could ask you to prove one of them, but if I don't ask you to prove it explicitly, then you can just assume that you can remember this. Now the trick to remember is, if the trig function has a co in its name, the derivative will have a negative sign in front of it. If the trig function doesn't have a co in its name, the derivative won't have a negative sign in front of it. And that's really why we put co in front of cosecant, even though it's 1 over sine. So the purpose of the co is to tell us the derivative will have a negative in front of it. So the derivative of sine is cosine. The derivative of cosine is negative sine, because the function was cosine, so the derivative has a negative in front of it. So sine, the derivative is cosine. Cosine, the derivative is negative sine. Secant is 1 over the cosine. The derivative of secant is secant tangent. Cosecant is 1 over sine, but since it's cosecant, the derivative is negative cosecant cotangent. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. And if you study these for a little while, you'll notice that there's a pattern here. Sine and cosine, cosine and negative sine. It's really the same pattern, except the co has a negative in front of it. The derivative of secant is secant times tangent. The derivative of cosecant is cosecant times cotangent, with a negative in front of it because it was cosecant. The derivative of tangent being secant squared, the derivative of cotangent is negative cosecant squared. So you memorize these 6 derivatives, but in reality you can prove 3, 4, 5, and 6. To prove 1 and 2, you have to actually use the limit definition, which is the long way we did it way back in the beginning of chapter 3. But you can prove 3, 4, 5, and 6 just by using product and quotient rules. So you can find these in the book as well. Memorize these 6 trig derivatives, because later on they're really important to be able to use. And if you take calculus 2, you use these derivatives a lot of time to integrate, which is finding a derivative backwards. So what we're going to do first is verify some of these. Well, notice here's the note. Trig functions that have a co in it have a negative derivative. But here's the first one where I ask you to actually prove one of these. The first one says, if f of x is the secant of x, show f prime is secant tangent. So the secant of x, if I want to find the derivative of secant of x, and I don't want to memorize it, then I have to turn it into sines and cosines. Sine goes to cosine when you take the derivative. Cosine goes to negative sine when you take the derivative. Those are the only 2 you have to know to be able to prove the rest. So to do this derivative, I'm going to write secant in terms of sines and cosines. And secant actually is 1 over the cosine of x. So now when I look at this, I see that I'm dividing 2 things. So if I want to find the derivative, I'm going to have to use the quotient rule. Remember, the quotient rule is low d high minus high d low over low squared. So let's figure out what the high one, or the top one, is. I'm going to use u's and v's because the function has an f in it. But u is the number 1. That's what's on top. And since 1 is a constant, when I take the derivative, I get 0. V is the one on the bottom, the low one. That's cosine of x. And I've memorized this one. The derivative of cosine is negative sine. So now I can put these together in the quotient rule to find the derivative of f of x. The derivative is low. The low one is the cosine of x. Times the derivative of the high, that's u prime, which is 0. Minus the one on top, which is the number 1. D low, which is the derivative of v, negative sine x. All over low squared. So that would give me cosine squared. So I'm going to simplify this so I can show you that we get secant tangent out of it. 0 times cosine is 0. So what I have on top is negative sine x over cosine x cosine squared x, excuse me. So I have sine x over cosine squared x. That's a correct derivative. However, I want to write it as secant tangent, so I'm going to do a little bit of algebra here. Remember, the secant is 1 over cosine, and the tangent is sine over cosine. And notice if I multiply these two things together, I get 1 times sine x, which is sine x on top, cosine x times cosine x, which is cosine squared at the bottom. And 1 over cosine is the secant, and sine over cosine is the tangent. So we've just shown that when I take the derivative of the secant of x, I get secant tangent. To show that, I had to use the quotient rule. And I really had to write everything in terms of sines and cosines. And that's how we can prove the other ones. Write everything in terms of sines and cosines, and then use the product or the quotient rule, and you'll be able to get the derivative out. It's better to memorize these. However, I could ask you to prove them explicitly, like this example, and that's how you do it. You turn it into sines and cosines. And we can look at another one of these. How about the cotangent of x? Show that the derivative of cotangent is negative cosecant squared. So we're going to do this one next. So if I want to take the derivative of cotangent, I have to write it in terms of sines and cosines. Cotangent is cosine over sine. Well, again, I have my u and my v. My u is the one on top, which is cosine of x, and the derivative of cosine is negative sine. My v is the one at the bottom, which is sine of x, and the derivative of sine is cosine. So now I can use the product rule to start to find this derivative. So remember the derivative using the quotient rule, not the product, the quotient rule. It's the low one, that's the sine of x, times d high, the derivative of the top, which is negative sine x. So that's low d high minus the one on top, high, times the d low, the derivative of the bottom, which is the derivative of v, which is cosine of x. So low d high minus high d low all over the bottom squared. And when I put this together, I get negative sine squared of x minus cosine squared of x over sine squared of x. And I'm going to do a little bit of algebra, and I'm going to factor a negative 1 out of the top of that. When I factor a negative 1 out, I have sine squared plus cosine squared on top, and I have sine squared on the bottom. Remember, sine squared plus cosine squared, the Pythagorean identity, tells me that that's just the number 1. So what I end up with is negative 1 over sine squared x, which is negative cosecant squared of x. I'll write that down again so it looks appropriate. So we've just proven explicitly, using the derivative of sine and cosine and the quotient rule, that the derivative of cotangent is negative cosecant squared. So that's the idea behind these if I ask you to prove it explicitly. You go ahead and write it in terms of sines and cosines, and then take the derivative and use the product or quotient rule. We have a couple other ones. Let me erase this one real quick so I can do the one I erased before. The one that I erased before asked me to find the derivative of the tangent of x over 1 plus secant of x. To find this derivative, I'm not asking you to show something you're supposed to memorize. So you don't have to worry about turning things into sines and cosines and proving the ones to memorize. You can just use your memory of those. But I still need to use the quotient rule because I'm dividing two functions. So to work this out, I'm going to let u be the one on top, in this case tangent of x. The derivative of tangent I memorized, it's secant squared x. v is going to be the one on the bottom, 1 plus secant x. V prime is the derivative of 1 plus secant x. The derivative of 1 is 0. The derivative of secant is secant tangent. Notice I just memorized those. I didn't go and prove them. But now I can use the quotient rule again to find the derivative of the overall function. So to find f prime, it's low d high. The low one was 1 plus secant x. The derivative at the top was secant squared minus high d low. The one on top is tangent x. The derivative at the bottom is secant tangent. And then it's all over the bottom squared. So it's all over 1 plus secant x squared. You don't need to simplify this further. You've used your derivatives and the quotient rule to come up with the form of the derivative of this function. Now if you'd like to work it out further, you could work it out further and make it look prettier. But in reality, that's all I'm looking for when I ask you to find the derivative. And note, you didn't have to prove the derivative of tangent or secant. You just memorized those in this case. So I want to do one more example where we use these derivatives to find an equation of a tangent line. And remember, a tangent line is, the slope of the tangent line is given by the derivative of the function. So if I ask you to find a specific tangent line at a specific point, I'll need the derivative to find the slope of that tangent line. So this problem is in 3.4 in the book. It is problem 50 in the book. But it says, find an equation of the tangent line and then the function they give me is 4 sine x cosine x. At the point x equals pi over 3. I'm sorry, I had pi over 4 originally, but the problem here is pi over 3. Well, remember, when you find the equation of a tangent line, here's how we write the equation of a line. Now when we do this, x1, y1 is a point on the line, and m is the slope. So I need to come up with a point on this line and the slope of this line. Coming up with a point on this line isn't too bad. I know that the x value is pi thirds. If I want to find the y value, I take pi thirds and plug it in to f of x, because f of x tells me the y value. This stuff in red is just how we write the equation of a line. So we're going to figure out all this stuff and then write the equation of the line now. So I take pi over 3 and plug it in here. The y value is 4 times the sine of pi thirds times the cosine of pi thirds. Now you can use your calculator to figure that out. Make sure you're in radian mode, otherwise you won't get the right answer. Or you can use reference angles. Pi over 3 is like 60 degrees. So the sine of 60 degrees is root 3 over 2, and the cosine of 60 degrees is 1/2. Oops. Now again, if you use your calculator, you get a decimal approximation, which is perfectly acceptable. But in this case, the y value turns out to be the square root of 3. Notice I plug it into the original function to find the y value. But I also need to find the slope. And the slope of the tangent line is the derivative. So to find the slope, I need to find the derivative of my function. Well, to find the derivative of this function, I'm going to need to use the product rule, because I'm multiplying together two functions of x. So to use the product rule, I can let u be 4 times the sine of x. The derivative of sine is cosine, and 4 is a constant. I can let v be the other function, cosine of x, and the derivative of cosine is negative sine. So I'm going to figure out what the derivative is, and then I'll plug pi thirds into that to figure out the slope of the tangent line. So according to the product rule, the derivative is u prime, that's 4 cosine x, times v, that's cosine x, plus u, that's 4 sine x, times v prime, which is negative sine x. So now I can calculate what the derivative of this function will be. The derivative of this function is 4 cosine squared x minus 4 sine squared x. And so to find the slope, I plug pi thirds into the derivative. So I have 4 times the cosine squared of pi thirds minus 4 times the sine squared of pi thirds. Again, you can use your calculator or you can use reference angles, but the cosine of 60 degrees, pi thirds, is 1/2, and the sine of 60 degrees, pi thirds, is root 3 over 2. And remember, I'm squaring the sine and the cosine. So that's 4 times 1/4 minus 4 times 3/4, which works out to be 1 minus 3, which is negative 2. The slope is negative 2, and the point is pi thirds square root of 3. So I can use this information to write the equation of my tangent line. Y minus y1 equals mx minus x1. So remember, you take the point and plug it into the original function for the y value. You plug it into the derivative for the slope. So this is the tangent line equation. Here's the form it's going to take. And now I just replace the things that I just found in this equation. My y1 is the y value. That's the square root of 3. My slope I found by plugging into the derivative. That's negative 2. And my x value they gave me at the very beginning is pi thirds. Now again, if you did this with your calculator, you're going to get decimals when you work this out, which is totally acceptable. So my equation of the tangent line is y minus root 3 equals negative 2 x minus pi thirds. This is a completely acceptable equation. It's called the point-slope form, and I'll accept that without any problem. So here's my equation of the tangent line. Plug the y value into the function for the square root of 3, or plug the x value into the function to get the y value. That's where my square root of 3 came from. Plug the x value into the derivative to get my slope. That's where negative 2 came from. And so when you deal with trig derivatives, if you need to prove anything, you turn them into sines and cosines. If you don't have to prove anything, then you can just assume that you've memorized those and you can work them out.